FHV for level, we know the equation for FHV, we have used it. The percentage of trucks, 15%. 5. Now, equivalency factor for level terrain is 2. Okay, just believe me because I remember the value. So give me the FHV for level. Then we'll do the same thing for upward and downward as well. .87. Okay. Okay, now so I need now the equivalency factor for upward condition. Okay, if I go there, I have a table for that. Okay, now the mix is given as heavy mix. Okay, so heavy mix means 30% SUT, 70% TT. This is the mix which is given. The table which we used yesterday was for standard mix, which is the reverse of heavy, 70% SUTs and 30% TT. Okay. So 4.5% gradient, which is this one, 2 mile length, which is this one. Okay, this range more than 1 mile, and 15% trucks. So the factor is 3. Okay, 3 minus 1. How much is this value then?
Doctor, 0.77.
Okay. Then you do the same thing for downward as well. This factor will change. For downward means less than 0, right? Negative. So factor is 2.02. How much?
Doctor, I have a question.
Yeah.
We have a heavy mix, right?
Heavy mix.
But from the table, aren't you taking the equal mix values?
Oh, sorry.
It should be the heavy mix values.
Yeah, heavy mix value, 3.11. Sorry for that. 3.11. Okay, so give me the correct value here. I think it will be 0.7 something. And this one, am I taking the right value here? 2.04. 2.04. Okay. 2.04.
Doctor, the first one will be 0.76. Yeah, for the second one will be 0.87.
Okay, so now you can see level and downward are same. They are same. So I don't have to do 2 sets of calculation for them. I can do 1 calculation for level and downward, and then I can do another set of calculation for upward. Okay, so FHV is done. Okay, FHV is done. Now for calculation of maximum service flow rate for level of service C and D, in the question they are saying they want to maintain level of service C or D. Okay, either maintain C or D is also acceptable. Okay, so I need maximum service flow rate for level of service C and D. Okay, how to do it? I will explain the procedure. Okay, I will sketch a diagram here, but and the exact values are already given in the slides in the book, so we will directly take it. Okay, so focus on the procedure. Obviously, we cannot draw the graph here in the class. Okay, you have to do it on a graph paper with calculator, pen, and so on. So First of all, you need to, for finding out the maximum service flow rate, you need to draw the diagram between speed and flow. For your highway, you have to plot a graph between speed and flow. Okay, speed on the y-axis and flow VP on the x-axis. Okay, now this graph should start from FFS. So FFS is already calculated. Okay, so the first value of the graph will be FFS. From this point onwards, you will draw a straight line. A straight line. It doesn't look straight, but believe me, I am trying to draw a straight line. Okay, draw a straight line up to what point? Up to a point which we call as a breakpoint, BP. Okay. So for plotting this point, the graph, I needed the free flow speed, which I just calculated, and I need a breakpoint. Okay. So the equation of breakpoint is given. Okay, so we are taking the values from here. Breakpoint equation 1000 plus 40 into 75 minus FFS adjusted into the capacity adjustment factor. Now again, no adjustment conditions are given. No adjustment conditions are given. So whatever FFS I've calculated, that is the final value, and I don't need these factor, this factor as well. This will become 1. So I can directly calculate the breakpoint. Plus 40, 75 minus 73.6. So you give me this value.
It will be 1056.
1056 passengers per hour per lane. Sorry, passenger cars per hour per lane. Okay. So up till this point, the line is straight. Okay. Then the last point on the graph is capacity. Okay. The last point for the graph is capacity. So let us calculate the capacity as well. And the equation for capacity is this one. Okay. 2200 plus 10 times speed minus 50. How much is this?
2436 Doctor.
2436 per hour per lane. Okay, now I have a maximum limit here, that whatever value you are calculating should not be more than 2400. Okay, and the value which you have just calculated is more than 2400. So that means I have to take this value. I'll discard the value from the equation. I'll take this value. Okay, so capacity is more than 2400. So C equals 2400 passenger cars per hour per day. So whenever you exceed the maximum value, you will take, you will discard it and take the maximum as it is. Okay, so I have the last value on the x-axis then. Okay, so this curve should end here, which is capacity. Okay, now how to join between these 2 points? I have to join it with a curve. Okay, so to join with a curve, I must calculate 2 or 3 points between these 2 values. So this value is BP and this value is C. Between these 2 points, I need to calculate some y values. Okay, the value for speed. Okay, so between these 2 points, the curve equation is this one. This one. Okay, this is the equation of the curve between BP and capacity. So I will start. I will just write the equation for one of them. Okay. This is the point you are trying to calculate, the y ordinate, and This is how you will calculate it. Now capacity you already calculated, and then you said we will take the maximum 2400 divide by density at capacity, which is fixed at 45. So this will not change. Okay, so 45. Then you multiply VP, and this is the value you are changing. Okay, so now you will select a value which is more than the breakpoint and up to capacity. Okay, this is the value which will change. So you are calculating the value of speed at different values of VP. Okay, and the criteria is that whatever values you are trying, it should be more than BP 1056, and you can go up to capacity. You can go up to capacity, which is 2400. Okay, so try any value which is more than BP, and you can go up to capacity. So first of all, let's say I will try 1200. Okay, because BP is 1056, so any value more than 1056 is allowed. Okay, minus BP, which is 1056. Okay, to the power A for freeways, the A is 2. Okay, it is given in the table on the next slide, and this is complete thing in the numerator. Then I go to the denominator, and capacity 2400 minus 1056. Power 2. Okay, so this is how you calculate the S value. So this S value is at 1200. Okay, so x-axis is 1200, and whatever you get from the answer, that will be your y-ordinate. Okay, then you can try maybe 1500, for example, 2000. Okay, just try 3 and 4 values, so you can plot 3 to 4 points between BP and capacity. Okay, so let's say these are the points which I have calculated, which I have tried and calculated the S value for. Okay, and like I said, you should calculate the S value at capacity as well. Okay, so make VP equal to capacity and calculate the S value. Okay, so now you will join these points and it will become the required curve.
Doctor, 3 points are enough, or you need more to be more accurate?
3 points are enough. If you include the capacity as well, like capacity is separate. Apart from capacity, 3 points are enough. I think they should be enough because it's the same equation. Okay, normally for so you have the start point and you have the end point and plus 3 more points. So basically 5 points on the curve. So 5 points are enough. The curve is not so long. The curve is very short. Okay, so so you plot these points and then join them. You have the curve. Okay, then you have the curve. Now on this graph, you have to plot diagonal lines or sloping lines which are representing the level of service you want. First of all, you can have a diagonal line directly without any calculation, which is for level of service E. So E is the point at capacity. Okay, so you join the point of capacity with the origin, that is the line for level of service E. Now in the question they said either they want to have level of service C or D. So I need to plot 2 more lines on this graph which represent level of service C and D. Okay, now if my free flow speed had been equal to the free flow speed already taken in the book, I could have taken the values from this graph, and for this graph the values are given in the table. Okay, but my free flow speed is 73.6 and here it is either 75 or 70, so I cannot use the graph directly. Okay, so what I will do is I will, like I said, that's why we are plotting our own graph. So first of all, you will take the maximum density for level of service C, which is 26, and the maximum density for level of service D, which is 35. Okay, for C it is 26, for D it is 35, and you will take the inverse of it. Okay, that will be the slope of line representing the level of service. So 1 by 26 is the slope of the line representing level of service C, and 1 by 35 is the slope of the line representing level of service D. Why I am taking the inverse here for the slope? Because slope of this graph will be speed upon flow, right? Speed upon flow. And density is inverse of that, flow upon speed. Okay, so that's why I'm taking the inverse. So give me these values, the values of the slope. .4, okay, for the first value. Okay, fine. Give me the slopes. So he's saying this value is 73.4. .038 and 0.029. Okay. Now 0.038 means 3.8%, or 0.038 is tangent theta. Okay. And 0.029 again means 2.9%, or tangent theta equals to 0.029. Okay. So now draw a line again from the origin. Okay, which has a tangent theta of 0.038. Okay, so let's say this is the line. So this line represents level of service C. Okay, and draw another line which has a tangent theta equals to 0.029, and let's say this is the line, and this line represents level of service D. Now, why I have done all this? I have done all this to find out maximum service flow rate. Maximum service flow rate for level of service C and D. Okay, so what will be the maximum service flow rate? The intersection points of these lines. So you can see the line of the level of service C line is intersecting at this point. So this will, you take the value from the x-axis. This is maximum service flow rate for C. Okay, and then you do the same thing for the line intersecting the curve for level of service D, and this will become the maximum service flow rate for D. Okay, now they have already done it in the book, and if you feel that my explanation was not good enough, you can go to the book and read their own explanation. Okay, maybe it will help you better. Okay, so they have already plotted the curve, and then they plotted the lines for C and D, and they found the maximum service flow rate for C, which is 1747, and then the maximum service flow rate for D, which is 2108. Okay, and then they calculated the we have already calculated the heavy vehicle adjustment factor as well, and now they are calculating the number of lanes. So design volume is already given in the question. 0.85 is the peak hour factor. 1747 is the maximum service flow rate for C. Now C is what we are targeting actually, and D is acceptable. Okay, so at the start of our calculation, we are doing everything for the target value. Target value is C. Okay, so you can see in all cases for level upward and downward, they are taking the maximum service flow rate for C. Okay, so you take maximum service flow rate for C here, and 0.87 is the heavy vehicle adjustment factor for that terrain condition. Okay, so you have 2.09 lanes for level terrain, 2.39 lanes for upgrade, and 2.11 for downgrade condition. Okay, so in each case you are getting 2 point something lanes, right? 2 point something lanes. So what do you say? Should I provide 2 lanes or 3 lanes? What is your decision? Should I provide 2 lanes or 3 lanes? Tell me. In this case, should I provide 2 lanes for all terrain conditions, or should I provide 3 lanes?
Sorry, doctor, can you repeat the question?
In each case, the equation is giving you 2 point something as an answer for number of lanes. Okay, so you cannot provide 2.09 lanes, right? Either you provide 2 lanes or 3 lanes. So how many lanes should be provided? 2 or 3? Hashim is saying 3. What about you?
I guess Doctor 2,
Why?
because I guess 3 may not be economical because it covers the highest values.
Yeah. Actually, in this question, you can try and provide 2 lanes as well. In this question, only in this question. But if somebody says, I want level of service C after my design, then you have to provide 3 lanes. Okay. If somebody says, I want level of service C, because level of service C is what they want actually. Okay, D is acceptable.
Okay. Depend on the level of service they want.
Yeah. So level of service C is what they are preferring, what they said that we want level of service C. Okay, so that's why we took the maximum service flow rate for C. Okay, this is the reason. So if somebody says that I only want level of service C, nothing else, then you have to provide 3 lanes, because if you go for less than what they have already calculated, the level of service C will not be maintained. Okay, you see the value here is, for example, 2.09. So if you provide 2 lanes, then you are providing less than the required value for level of service C. Okay, so this is not allowed if only one level of service was given. But in this question, they gave me 2 possible values. I can have level of service C, and I can also have level of service D as well. It is also acceptable. Okay, so let us check what Hussein was saying, that if you go for the economical answer, if you try to provide an economical highway, what will happen then? Are we fulfilling the minimum standard or not? Okay, so in that case, I need to calculate the maximum service flow rate. Well, how much maximum service flow rate I will maintain if I provide 2 lanes. Okay, so I'm trying to calculate maximum service flow rate using this equation now. Okay, and n is kept as 2. Okay, so n will be 2. So it will be 2700, the design volume, divided by 2 lanes into 0.85, the peak hour factor, into, again, I have to do it separately for level and upward, and level is same as downward as well. So keep it in mind, FHV was same. So I will do it separately for level. So this is for level and down and downward. Okay. So how much is MSF here? And then you do the same thing for this will become for upward. So give me the MSF values. Two 2090. 2063. So 2063 is this one, right? Which one is 2090 and which one is 2063? Can somebody cross check it? Tell me the exact values. The first one is 2090. Okay. And the second one is?
Second one, Doctor, is 2062.6.
Okay, now I need to check if I provide 2 lanes, do I exceed the maximum service flow rate of D? Okay, so when you provide 2 lanes, you are getting this in the level and downward terrain, and then you are getting this in the upward terrain. Okay, so am I exceeding the level of the maximum service flow rate of D in any case? No. The answer is no. The maximum service flow rate for D is 2108. So even if you provide 2 lanes, you are not exceeding the maximum service flow rate for D. Okay, so in both cases, you are still maintaining the minimum level of service. Okay, so if you want to go for economical design and you provide 2 lanes, then still you will maintain the minimum level of service, which is D. Okay, but if you go for the required one, then you should provide 3 lanes for all cases. Okay, and this extra step, the last this thing which I have done just now was only done because I had 2 options. I can provide level of service C and D. Both options were acceptable for the client. But if the client says I only want level of service C, then this last step is not required. Okay, you will say you need 2 point something lanes, so make 3 lanes on the road. That's it. Provide 3 lanes on the highway. That's it. You stop there. No extra calculation required. Okay, so this extra calculation was done because the client gave me 2 options. First is 1826. Okay. Yeah, it makes sense. Okay, because you are dividing with 0.87 here, then you are dividing with 0.77 here. This one should be higher. Okay, so this makes sense. Anyways, the logic remains the same. Okay, you provide 2 lanes, it will be economical, but you will maintain minimum level of service. If you provide 3 lanes, you are achieving the required level of service. Okay, then you leave it up to the client whether he wants to save the money or he wants to stick to the required level of service. Okay, but if the client told you no other option for you, just give me number of lanes for level of service C, you'll tell him provide 3 lanes. That's it. Okay. Okay, then we have another example which is related to growth rate. Okay, it's a 6-lane urban freeway, free flow speed is given, rolling terrain, traffic consists of 10% trucks, standard mix. Okay, other standards conditions apply, so no adjustment factors again, no CF and SF. Peak hour factor on the facility is 0.92. Current traffic volume is 3600 current in one direction, and this volume is expected to grow 6% every year. So 6% will be increased in the number of vehicles every year. Okay, and it will remain, the growth rate will remain 6% for the next 20 years. Okay, what is the current level of service? So this is what we have already done previously, right? But now they are also saying what will be the level of service after 5 years, 10 years, 15 years, and 20 years. Okay, there are 2 ways in which this example can be done. Okay, one is what we have already done yesterday. You can adopt the same procedure and do it for every year separately. Okay, so when you are doing it for the current year, take this volume. When you are doing it for the next 5 years, the volume should be increased by 6% for the next 5 years, and then that will become the volume. And the same thing for 10 years, 15 years, and 20 years. The procedure will remain the same. The procedure will remain the same, like we did yesterday for the freeway. Go back and check that example. We calculated VP and BP, and then we calculated density. So you will do it for each year separately. You do it for the current year, then for 5 years, 10 years, 15 years, and 20 years. Okay, so in this way, you will do the calculation 5 times. The calculation which we did yesterday for one freeway for one time, you will do it multiple times, one for each year. And each year, the volume will change. Each year, the volume will change. Okay, but the good thing in this question is free flow speed is given. So I don't have to calculate it. So the one step from that example will be reduced. Okay, free flow speed is already given, don't have to recalculate it, don't have to calculate it at all. Okay, so this is one way of doing it, but we will do it in another way which is possible only because the free flow speed is 65. The other method which I'm going to explain just now is only possible because the free flow speed is 65. Why is that important? Because in the highway capacity manual and in our textbook, they have given me the speed flow curves for the highways with few free flow speed values. Okay. So for example, okay, so the speed flow curves for these free flow speeds are already plotted. Okay, this is for freeway and this one is for multi-lane highway. So if you are dealing with a multi-lane highway or a freeway which has free flow speed which are given already in the graph, you can directly take the values from the graph. And even you don't have to take the values, because for these graphs values are already tabulated. So the maximum service flow rate for each level of service is already given if the free flow speed matches this column exactly. So if your free flow speed is 75 or 70 or 65, like what we have now, the free flow speed is what? 65. So that means I don't need to calculate my own values. Okay, I don't need to apply the procedure which I did yesterday. I can do it using the service flow rates given in this table. So this table is saying if the free flow speed is 65, then the maximum service for A is 710, for B it is 1170, and for C it is 1630, and so on. Okay. Now I can compare my volume with these flow rates, and then I can decide about the level of service. Okay, I can compare my volume with these flow rates and I can decide about the level of service. The only thing which I need to do is these flow rates are in passenger cars per hour per lane. The flow rates which are given in this table are in passenger cars per hour per lane, but the volume is in vehicles per hour. So I need to do some conversion. Okay, so this is what we will do just now. So speed given 65 miles per hour, and now I will put a table here. Okay, so level of service, maximum service flow rate, which is in passenger cars per hour per lane. Okay, and the adjustment factors, the factors which you need to multiply. Okay, let me just write the factors. The factors by which you need to multiply. And I need another row as well for the service volume then. Okay, which will be in vehicles per hour. Okay, so level of service A, B, C, maximum service flow rates from the table 710, 1170, then 1630, then 2030 and 2350. Okay, now each value will be multiplied by the same factor. Okay, yes, number of lanes. Okay, how many lanes I have? It's a 6-lane freeway, so number of lanes in each direction is 3. I need the peak hour factor, which is 0.92. Okay, and then I need the FHV. Okay, so let us calculate FHV here. It's for rolling terrain. FHV is for rolling terrain. So 1 divided by, what is the percentage here? 10%. rolling terrain, the equivalency factor is 3. How much is FHP here? $710. Okay, what did I write? Okay. .83. Okay. So now you can give me the service volume for each level of service. All of them will be multiplied by the same factors. All these values will multiply by the same factors. So give me service volume for each level of service then. $16.26. Okay, next. $2680. Okay. Next. 3733. 3733. Then we have 4649. 4649. 5382. 5382. Okay, now if your service volume exceeds a particular value in this table, that means that level of service doesn't exist. Okay, if your service volume exceeds a particular value from this table, that means that level of service doesn't exist. So for example, the current volume is 2600. Okay, let me recheck. The current volume is 3600, sorry, 3600. Okay, so now in the current year, level of service is, so you can see 3600 exceeds the value for A, it exceeds the value for B, but it doesn't exceed the value for C. So the current level of service is C. Okay, the values which you have exceeded are not applicable. Okay, so you did not exceed the value of C, so C is the level of service. Okay, the current volume is 3600. Okay, now for the future years, to calculate level of service for 5 years, 10 years, 15 years, 20 years, I should have the volume for all these years, right? And this step is applicable whether you are doing it in this manner or like we did yesterday, because you need the future volumes. Okay, so now we will calculate the future volume. So the equation for calculating future volume is you take the present volume 1 plus I, where I is the growth rate, to the power n. N is the number of years in which you need the value. So if you are doing it for 5 years, then it will be current volume, which is 3600, plus I is 6% every year, so 0.06 to the power 5, because I'm calculating after 5 years. Okay, and the same thing can be done for 10 years, for 15 years, and 20 years as well. Only the value of n will change. Okay, so give me these values. Five years is 4818. Okay, now don't calculate any value after 10 years. Just wait. It's Vikas per hour. Because at 10 years you got 6447. Okay, now let me tell you what is the level of service after 5 years. What is the level of service after 5 years? The value is 4818. What is the level of service after 5 years? 4818. You are above D. D is 4649. Okay, to have level of service D, the volume must be less than 4649. Then E, yes, it is E. Level of service is E. Okay, and what is the level of service after 10 years? So you have exceeded the volume for E as well. 5382, you have exceeded it. So what is the level of service now? No. After 10 years, you have already exceeded 5382. E remains up to 5382. What happens after 5382? Yes, F. So now we have level of service F. Okay, and this is why I asked you to stop calculating for 15 and 20 years, because since the traffic keeps on increasing, so the level of service will not change. It will remain F. Anything after E is F. Okay, so whatever you will calculate for 15 years and 20 years, it will be more than the volume for E, right? It will be more than 5382 because it has already become more than the volume for E after 10 years. So after 15 years and 20 years, since it keeps on increasing, so it will not go back to E or D. It will remain in F. Okay, so in after 15 years and after 20 years, the level of service is F. Okay, so once you have exceeded E and the traffic keeps on increasing and you don't do anything about it, it will not change back to and less than F. Okay, it will remain F and it will continue. Okay, now for example, somebody asks and says that I want to avoid getting level of service E. I want to avoid getting level of service F. Sorry, getting level of service F. So I want to know in which year exactly level of F happens. Okay, so you see after 5 years level of service was E. After 10 years it became F. So somewhere between 5 and 10 it changed from E to F. So in which year exactly it became F? So I will use this equation. Okay, but now I will use it to calculate N. Okay, so I will put the value equal to the volume of E, because when the highway reaches this volume, it will be the start of level of service F. So 5382, okay, and 3600, the present volume, 1 plus 0.06, the growth rate, and I'm trying to calculate N here. Okay, and if you calculate N from here, it will be approximately 8, approximately. So approximately after 8 years or in the 8th year, the level of service will move into F. Okay, so whatever the government wants to do, they should do it before the 8th year. Okay, so what I have done here, I put the capacity as the future volume, and I'm calculating in how many years it will reach capacity, because after capacity it will become F. Okay, so N will be approximately 8 from here. So in the 8th year, the highway will become, the highway will reach level of service F in the peak hour, and whatever you want to do to avoid it, you should do before the 8th year. Okay, and what can you do? There are some things mentioned here, some points mentioned here. You can apply zoning, you can promote public transportation, you can improve alternative facilities, you can change the working hours and so on and so forth. You can go through these points, okay, yourself. I will not explain them. So there is one more example remaining in this topic, which I will cover inshallah on Thursday inshallah. I was trying to avoid it, but the first example was too long. Okay, and I tried to explain it because we couldn't do it step by step in the class. So I tried to explain as much as possible. So any questions, any confusion, any clarification you need, please go ahead. Anything related to any example? Okay, have a nice couple of days. See you guys on Thursday, inshallah. Assalamu alaikum.